Okay, now let's move on to the challenge problem of the chapter 3, of chapter 13. This one will talk about the power of the point. So the first problem is let the circle O, then we have the OP. We have the OP is parallel to, it's perpendicular to the OB, and PO is equal to the length of the distance of the diameter of the O. So now we know if it's length of the diameter of the O, then we know here is the radius, and here is another radius, and if we extend, there is another radius, right? So we have the power of the P. Now we know the P, this is the C, okay? So PC times the PD, okay, is equal to the PA times the PB, okay? Now we can calculate it, okay? So here is the radius of the R. Now we have the PB is equal to, in the Pythagorean theorem, is the R squared plus 2R bracket square is the root 5R, right? Okay, now we have the PC is equal to the R, and the PD is equal to the 3R. Now we can calculate. So the PC times PD is 3R squared equals to the root 5R times the PPA, right? So that's why we have the PA is 3 over root 5R. Okay, now once we have the PA, we can calculate the AB, right? So the AB is equal to the PB is the root 5R minus the 3 over root 5R, right? So then it is the root 5, then 2 of the R, okay? Now the PA over PAB, this one together, we can calculate the PA to the AB is equal to the 3 over 2. Okay. So next. So a chord, okay? Now let's see. A chord PQ equals RS, okay? And meet at the point X. PQ, RS, these two chords are equal, right? Meet at the point X, okay? So we are, from this figure, we are trying to prove the Rx equals the Qx, right? Px equals Rx or Qx equals Rx, okay? So for this figure, if we can prove the Rx equals Qx, okay? And if you want to flip it, P prime or Q prime, then we prove the Px equals Rx, okay? Now let's see the center of the O, okay? So now let's drop the height from the center of the O to the two equal chord, okay? So now let's see if the P, this is the M and N, right? So from the center to the chord, it's perpendicular, it's just a perpendicular bisect of the chord PQ. So PQ equals RS equals A, okay? Then we know, for example, this small, then we know this is small thing is equal delta, right? So it's A minus A, this is the A divided by 2, this is the A divided by 2 minus delta, right? And from this one, let's see, okay? Let's prove the triangle, the OXM is congruent to triangle, the OXN, okay? So now let's compare, let's list it, okay? So we have the OX equals OX, okay? And we have 90 degrees equals 90 degrees, Okay, and the other one is the since we are lengthening if the chord is the same length, okay, the height is also the same length. Let's see why. Okay, because the radius is the same, right? So the OM is equal to Pythagorean is the r square minus a over 2 square, right? The same reason, okay, you can prove the ON is equal to the r square minus the a over 2 square. Okay, so that's why you have the ON equals the OM. Okay, then ON equals the OM. Okay, so because it's a right triangle, right? So we have if one of the leg is the same or hypotenuse is the same, then these two triangles are congruent. Okay, once these two triangles are congruent, okay, means this is the delta, this is also the delta, right? Once these are delta, we can see this one is a over 2, this one is also a over 2 minus delta. Okay, so that's why we have the Rx equals the Qx here equals a minus half a minus the delta. So they are the same. Okay, so the key is for here, if you see the chord is the same, the height to the chord is also the same. Okay, you always length to the height because here is the perpendicular bisector. So, and also there is a triangle here. There's a cyclic quadrilateral, or there are two right triangle here. This is we always use. Next is Jake is working on a problem in which the chord A, B, and CD. Okay, so here is a circle. Okay, and we have a chord of the AB, and we have a chord of another CD. Okay, so we extend past the B and D. Is a meet at the point P. Okay, so he is given the PB, AB, CD. He is given the PB, AB, and CD, and he mystically used the power of a point improperly of the PB. Okay, we're supposed to use the PB times PA equal. This is the should. Okay, this is the real case. Okay, then it's the PD times the PC. Okay, so but he used the PB times the BA is equal to the PD times the CD DC. Okay, so and he get the same answer. So prove that the question we have the AB equals CD. Okay, now let's do this. Okay, let's see the PB equals A, AB equals B, and the PD equals C, and the CD equals D. Okay, so we try to prove the B equals D. Okay, so now let's see. So what we should have, okay, is the A times the A plus B is equal to the C times the C plus D. Okay, and he said if we use this, we can also solve the correct. We can also get the right answer of the PD, right? So that means the C times D is equal to the A times B. So we get the right answer of the C, right? So from here, so C means C is equal to AB over D, right? So if we solve the C from this equation, okay, and we solve the C from this equation, this is the 1, this is the 2, right? So C from the 2 is equal to the C from the 1. That means if we apply 3 to 1, it's also satisfied, right? Also true. Let's put the C into the 1, okay? So A times A plus B is equal to the C is AB over D, okay? Then times the AB over D plus D. Okay, so we have the a square plus ab is equal to the a square b square over the d square plus the ab. Okay, so now we can cancel the ab. Okay, now we have the a square d square equal to the a square b square. In this case, we know b equals d. Okay, so this is exactly what we want to prove. Next, so AB are the 2 points on the circle with the center O, and the C lies outside of the center O. Okay, so we have a circle O with the center of the O. Okay, and we have an AB chord. Okay, so we have the AB is 24, and the C lies outside. BC is 28. Okay, and the OA, that's the radius, is 15. Okay, we want to find the OC. Okay, we normally always extending this. Okay, so we want to find the OC, right? So now we can see, let's put a point here, because we are going to use the power point, the power point of the C. Okay, so let's try to see what is the CD. Okay, let's use the CD as x. So CD times CE is equal to the CB times the CA. Okay, so CD is x, CE is x plus 30, that's the diameter, is equal to the CB is 28 times the 24 plus the 28. Okay, so that's why it's 28 times the 2 and the 5, 52. Okay, is x squared plus the 30x. Right. So now in this case, we can solve the x. Okay, let's solve the x. X squared plus 30x minus the 28 times the 52 is 0. So that means we can solve it is x equals to x equals to 24. Okay, so once we solve the x, okay, now you can see the OC is equal to the x plus the 15 is equal to 26 plus the 15 is equal to the 41. Okay, so next we have the circle C1 and C2 share the same center, so they are concentric circle. Okay, so we have the C1 and the C2, they are concentric circle, and the radius of the C1 is greater than the radius of the C2. So this is the C1, this is the C2, right? So here is the R1 and here is the R2. Okay, so we want to prove that it is impossible for a point to have the same power with respect to both circles if P is outside of the both circle. So if P is outside here, okay, what we want to prove is there is no way the P is tangent to the first circle is T1 and P is tangent to the second circle is T2. There is no way that the PT1 square is equal to the PT2 square. Okay, so this is the, we need to use the property that from the center to the touch point is 90 degrees. Right. So by Pythagorean theorem, we know the PT1 square is equal to the OP square minus the R1 square, and the PT2 square is equal to the OP square minus the R2 square. Okay, in this case, and if you want this same, there's no, you need R1 equals R2, but that's the contradiction. Okay, so we proved the A. So the same thing, we want to prove the B. Okay, so it's still concentric. It's still the same thing, R1 and R2. This is C2, this is C1. We want to prove inside the circle, the P, there's no way, there is no power point of the P. They make them the same, right? Okay, so if inside the P, okay, that means we can pass in the P and connect the center of the point, right? So that's why the power of the P, right? The power of the P, for example, this OP, let's say OP is the X, right? So the power of the P for the circle 2, okay, is equal to the R2 minus X, right? R2 minus X times the R1 minus X. I mean the R2 plus X, okay? The power of the C1 against the P is the R1 minus X times the R1 plus X. This is the R2 square minus X square. This is the R1 square minus X square. R2 doesn't equal to R1, so that's why there's no way this of power point is the same. Power of the point is the same. So this we prove the second problem. Okay, the last argument is still we have the concentric circles. Okay, so this is the O, this is the C2, this is the C1. Okay, we want to prove that it's at point some part of the point here. Okay, so we can have the equal power. Okay, so let's see the power of the P, right? So the P to the C1. Okay, let's see the OP is X. Okay, so P to the C1 is R1 minus X and R2 plus X. R1 plus X. Okay, the P to the C2 is equal to the it's the X minus the R2, right? And the X plus R2. So now let's solve this one. P power of the point P to the C2 is equal to the C1. Then we have the R1 square minus X square is equal to X square minus R2 square. Okay, so now we can solve is X square equal to the R1 square plus R2 square over 2. So now you can see the power of the point of the P is a circle. Okay, is a circle concentric to the R with the radius of X equal to the root R1 square plus R1 square plus R2 square over 2 square root. Okay, next. So we had, okay. Okay, so we have a triangle, XYZ. And we have circumscribed circles, right? Circumcircle, okay? We circumscribe this circle C is the triangle XYZ. And then we have a point of the W, okay? Then we have the WX and okay. this is the y, x and the z. Okay, so wx and yz meet at P. Okay, meet at P. So we want to prove if we have this case, if we have the equal power of the P, that means the Wp times the Px is equal to the Yp times the Pz. We want to prove W is also on the circle. Okay, so let's connect the WZ. Okay, the goal is we want to prove the YPX triangle is similar to the triangle WPZ. Okay, now let's see what's going on. Let's rewrite it. Let's rewrite as the YP over the PX is equal to the WP over the PZ. Okay, so YP over PX is equal to the WP over the PZ, right? And this angle also equal to this angle, right? So angle YPX is equal to angle WPZ equal alpha. So from here, we know these two triangles are similar. If these two triangles are similar, so we know this is the angle beta and this is the angle beta, right? So these two angle beta are all spanned by this chord of the xz, right? So now we know the y xzw is concyclic. Okay, so there are several ways to prove the 4 points are concyclic. Let me set aside here. Okay, the ways to prove concyclic quadrilateral. Okay, so several ways. Okay, so first one is two opposite angle is alpha beta 180. Okay, first way. The second way is to prove that the exterior angle is equal to this angle. Okay, the third way is using the power of the point. Okay, PA times PB equals to PC times PD, then the ABCD concyclic. OK， 中文我们叫切割弦定理。OK， in English is power of the point. OK, the fourth way sounds very basic. OK, but a lot of things very powerful. OK. To prove the ABC is have a circumcircle of C, and to prove ABC is this. Okay, then prove D. You can prove ABD. Sorry, prove D is on okay. To prove D is on circumcircle using OD is equal to OA, okay, where O is center of circle of triangle ABC. Okay, so here are some ways to prove the concyclic. Okay, there is the third one, the fifth one. Okay, so a circle is a beta and a beta. Okay, so they all spanned by the arc with the 2 beta. Okay, this is A, B, C, D. Okay, if you can prove that these 2 angles spanned by the same arc, so they are the same, you can also prove the A, B, C, D are concyclic. Next, so the 2 circles intersect at 2 points AB. Let PQ be a chord of the C1 and RS be a chord of the C2 such that they intersect at AB. For example, at X, we have the chord of the PQ. This is the C1, chord PQ, and the chord RS. Okay, now we want to prove the PQRS are concyclic. Okay, first, the power of point X on C1. Okay, we have the XP times XQ is equal to XA times XB. Okay, power of point X on C2. Okay, we have the XR times the XS is equal to XA times XB. From here to here, we know this one, right? According to power point, you can know the P, Q, R, S concyclic. Okay. Given 2 segments of A and B, construct a segment with length of this. Okay, so here, if we can cut in the segment of A and B, okay, we can try to make a construction of a right triangle, and here is the also the right angle vertices is on the perpendicular L, line L to the AB, right? And now this is the H. Okay, according to the projection theorem. Okay, 中文叫摄影定理。Okay. We have the H square is equal to A times B. So we have H is root of A times B. So here we can use the similar triangle, because here is the theta and this is the theta, right? Theta plus this is 90 and theta plus this is 90, so they are the same. And now we can have we know the A over the H is equal to the H over the B. So now you can see the H equals root AB. Okay, next. So we have an equilateral triangle. We have an equilateral triangle ABC. Okay, let's assume its length is 1. It doesn't matter. Okay, so let P be a point on the arc of the BC, and let AP intersect at the Q. Okay, BC at the Q. Okay, so we want to prove the 1 over PQ. Okay, it's 1 over PB and plus 1 over the PC. Okay, so let's using the let's use in the similar triangles. Okay, so we can see the triangle based on this angle is alpha and alpha, right? This is the 60 and this is the 60. Okay, so the triangle the AQC will similar to the triangle is the BQP. Okay, so now we know the we want to have the PB, right? I'll pick a PB and PC. Okay, so now we want to have the PB. So the BQ, the PQ over PB, okay, is equal to the QC over AC. AC is 1, right? Okay, so now we see the PQ over PB is equal to the QC. Okay, the second one is we want to use the PA, right? PC, right? We want to use the PC. So now you can see we have the PCQ is similar to triangle the BAQ. Okay, so in this case, the PQ over PC is equal to the AQ. The PQ is BQ, okay, and the PC is AB is 1. So we can see the PQ over the PC is equal to the BQ, right? From these two, we know the PQ, okay, over PB plus the PQ over PC is equal to the BQ plus CQ. Here we assume as 1, okay? So that's why we have the 1 over PB plus the 1 over PC is equal to 1 over PQ. Okay, next. So in this diagram, we have the AB equals 8, AP equals 2, and the PC equals 4. Okay, so we want to prove first is the ABE over CDE. Okay, so we know here is the arc, right? The 2 4 points are concyclic. So this arc, so here is the angle alpha, here is the angle alpha, right? And the 3 angles are the same, so that's why for the A, we know triangle BAE is similar to triangle the DCE. Okay, so that's why the area ratio is equal to the side ratio, right? So the AB is the side to this angle, to beta, and so that's why the CD is also side angle to the angle opposite to the beta. So that's why we can have the ABE over the CDE, okay, is equal to the AB square over the CD square. Okay, the B. Prove that the P. Prove that the PBC is and over the PAD. Okay, so we want to prove the triangle the PBC is similar to triangle the PDA. Okay, so you can see we have a common angle. This is the theta, right? So alpha and alpha, theta is the common angle. So that's why they are similar. Okay, so the corresponding size of the PC is corresponding to the alpha, and so PA is also corresponding to the alpha. Okay, now let's see the C. Okay, is we want to prove the PAE, we want to calculate the PAEC. PAEC is the quadrilateral in the middle, right? Over the BAE. Okay, so let me draw a big picture here. Okay, so we have the 2, 8. We have 2, 8. And we have the 4, 2, 8. We have the 4 to D, and the P, and the A, and the B. Okay, then we see this is the C. This is E. Okay, so we know the PA times the PB is equal to the PC times PD. Okay, so PA is 2 times 10 is equal to the 4 times the PD. So PD is 5. So CD is 1. Okay, so now we prove this one, right? Okay, now let's see let's see this area is X. Okay, so this area is M. This is M over 64, right? Okay, so now we know the PAB, the triangle, the PBC over triangle PDA, okay, is equal to the 4 square over 2 square is equal to 4, right? So this means the triangle X plus the M over X plus M over 64, okay, is equal to 4, right? So what we go is to try to calculate what is X over M, right? So X over M is Y plus 1. Let's divide by M here, right? Divide by M is Y plus 1 over 64. Okay, so now we can solve the Y. Okay, after you solve, the Y is 5 over 16. Next. So the equilateral triangle is inscribed in the circle. So here the circle, because it's the equilateral. Okay, so this one must be the circumcenter. Okay, then we have the midpoint of D and E. Connect connect to the point with the F. Okay, so we want to DE meet the circle, and we want to calculate the DE over EF. Okay, so this is, we can see, okay, because E is the midpoint, right? So we know the AOE must collinear and the height, right? So, and if we put the J here, okay, so we also know put the midpoint of J. Okay, now we know the O is the center of ABC, also the center of DEJ. Okay, so now we can try to, because it's a ratio, right? We can assume the side AC is equal to 2 for us to calculate easy, right? So 1, 1, 1, 1, right? So this side, the DE is equal to 1. Okay, so what we are trying to solve is what is the we are trying to solve is what is the EF, right? Okay, so now let's try to solve the EF. Okay, land on the midpoint of the M. Okay, here is the midpoint of the M, right? So now we can see, okay, so the OB, let's do the BJ first. BJ is equal to times 2 is root 3, right? So with because O is also the centroid, so the BO over the OJ is also 2 over 1, right? So that means this is the 1/3 of the OJ is 1/3 of the BJ, right? So OJ is 1 over root 3, and the BO is equal to 2 over root 3. Okay, and because the symmetry, the O is also the centroid of the DEJ, right? So that means you know the OM. You also know the OJ over the OM. Okay, this is the to respect to the triangle, the DEJ. Okay, you know the OJ over OM is also 2 over 1, right? So now you know the OJ is equal to 1 over root 3. Now you know the OM is 1 over 2 root 3, 2 times root 3. Okay, 1 over 2 times root 3. Okay, and also we know the OJ. We know the OB. OB is this, right? It's also the radius. Did you see it? OB is equal to OA and is also equal to OF. So this one is 2 over root 3. Okay, now we can try to use the Pythagorean theorem, okay, of the triangle OMF. Okay, you can use the Pythagorean trying to solve the MF is equal to the 2 over root 3 is the 4 over 3 minus the 1 over 2 root 3, right, is 1 over 4 times 3. Okay, now you can solve it. So it's 2 root 3, right, and this is the over 15. So this one is equal to the root 5 over 2. Okay, so if you solve the MF, you can solve the EF, right? So the EF is equal to the MF minus half, right? So EF is, okay, so we solve the EF, and with the DE is just 1, right? Yeah, so now the DE over EF is just a 1 over 2 over root 5 minus 1. So it's 2 root 5 minus 1 is equal to the 4 is 2 root 5 plus 1. Okay, so let's see this problem. Okay, so the segment IF is tangent to the circle at the I. So this is the tangent, okay? As shown at the diagram, and we are given the IF is 21 root 2. The IO is 20. The ON is 12. The RF is 18. And the OR greater than the OG. We want to find the OR, okay? So we have the 20 and the 12, right? So we can use the power point of the O, right? That means the 20 times the 12 is equal to the, let's see, the GO is X and the OR is Y, okay? It's equal to X times Y. Okay, and the other one we have the IF, right? So the power point of the F is equal to the IF square is 21 root 2 square is equal to the 18 plus times the 18 plus x plus y. Okay, so now you have equation. Okay, we are able to solve it. Let's do this. Okay, so let's see so this one is 18 plus x plus y is equal to the 21 times 21 times 2 over 18 is the 3 times 3 times 2. Yes, take out is 49. So x plus y is equal to 1 is equal to 31. And x times y is 240, right? So this means Pythagorean theorem, okay? We know the x, y are solution, are roots to quadratic equation t squared minus 31t plus 240 is equal to 0. Okay, so this when we have t minus 15 and t minus 16 is equal to 0. Okay, so we have the t1 is 15 and the t2 is 16, right? Because we are trying to solve the OB is OR is the longer one, right? So you know OR must equal 16. Okay, so chord ABCD are perpendicular at point P. So we have a circle of the O. Okay, chord ABCD are perpendicular at the P. So we have given the CP is 2, AP is 3, PD is 6. Okay, we want to find the following. First is OP. Okay, so here you can see we have the two chords, they are perpendicular, right? And in this case, we want to land this one and this one. Why we want to land this two? Because we know the M is the midpoint of the CD and N is the midpoint of the AB, right? So the power of the chord of the P, use the power of the point of the P is equal to the 2 times 6 is PC times PD is also equal to the 3 times the PB, okay? So it's PA times PB. So we can solve the PB is equal 4 first. So we know the PB equals 4, right? Now, because the M is the midpoint of this, right? So it's 2 plus 6 is 8. So we know it's half is the 4. So we know it's a 2. The other, this is the 4. And this is the 3 plus, this is the 3. PA is 3, right? The PB is 4, right? So total is 7. Half is the 3.7. So we know this is 0.5 and this is 3.5. Okay, so now we know it's 0.5. So in the right triangle of the OMP, right? So you can see the OP is equal to the 2 square plus the 1/2 of the square. So now you can solve it. Is equal to the 65 over 2. Okay, so that's it for the challenge problem of this chapter. Okay, thank you so much. Bye.